Okay, friends and neighbors, time now for installment 3 of 4 of our multicast series. Remember that this goes to the new chapter for the Packet Guide to Routing and Switching on multicasting, and in this particular one, we're going to focus on IGMP. So, now that we're going to get into the protocols, what is multicasting? So, multicasting is when we want to send IP datagrams to 0 or more nodes with a single IP address. So it's kind of crazy. We're used to the idea of broadcasting, spamming everywhere using those 255s, or if you're subnetting, using whatever the broadcast address is for your subnet, and then tying that to a layer 2 broadcast of all Fs in the destination MAC address. Now, multicasting is a little different. It's a little weird because a node is going to have a particular unicast IP address, and it's just going to blast out traffic to a multicast destination. That's what makes it a little weird. You do not need to be a member of a group to send traffic to a particular IP address, and it is going to be best effort, which means that we just forward things out. And that's actually the way that we would want it to be. You don't want to try to collect all the frames that you may have missed, because most multicast streams are video or game or audio or something like that, and getting the packets that you missed would be simply work to make the stream a little hard to understand. So we don't want to worry about that too much. Now, there are two parts to multicast. There's IGMP, and then there's PIM. And we're going to talk about both of these. And we really only need PIM if we're going to route this stuff. Again, it's a little weird because I have a particular IP address, and normally folks would talk to me at this particular IP address. And instead, what I'm going to do is forward this stuff out to a particular multicast address. And anybody that wants to listen into that particular stream will just start collecting those packets. All right, so it's a little weird. Takes a little bit of getting used to, maybe. So let's talk just for a moment about the RFCs. There are a lot of them. And we're currently in IGMP version 3 with lots and lots of work in between the versions. But if you want to start back at the beginning, you go to RFC 1112. And basically what ends up happening with these RFCs is that they're not, a lot of times you'll see that an RFC will obsolete the previous RFC. That's not what happens here. These are updates because functionality or messages were added onto the RFC. And what that means is that if you're trying to really understand what the point of the IGMP might be, and again, IGMP means the Internet Group Management Protocol, if you want to understand that, you have to go all the way back to the earlier version of the RFCs because it doesn't include everything. Later RFCs, as you can see here, include multicast listeners and then stuff for IP version 6 as well. So there you go. Happy reading. So I've got a couple of quotes here, so bear with me. I'll read the salient parts to us. In RFC 1112, so this memo specifies extensions required of a host implementation. Let me try that again. Host implementation of the Internet Protocol to support multicasting. So again, the whole point of this particular RFC is to support multicasting. Well, what does that mean? That means that the hosts had to be modified. The stack had to be changed to incorporate this. Now, an important point I'll make now, and we'll talk a little bit about it later, is that an important aspect of multicasting is that it wasn't supposed to interfere with the processing of IP packets. It wasn't supposed to make it harder. It was just supposed to make it an add-on. So there wasn't supposed to be a tremendous difference in the way things were processed, just an additional capability. Now, RFC 2236 adds the ability to report multicast group membership to routers, and we'll see how that works in a little bit because it's not always necessary to inform the routers. We do a lot of spamming of multicast messages, and then routers will ask for stuff because they have to know when it's time to forward multicast traffic to a particular network. But that was really the addition of the second IGMP RFC. All right, so RFC IP version, IGMP version 3 added the multicast listener discovery for IP version 6. And also really the multicast listener discovery itself, that whole process of being able to sort of supplement what was already going on. The idea here in a nutshell is that hosts will tell the routers about the groups, and then the routers will figure out how to get traffic to the destination. Now, depending on which operating system you have, you'll either default to version 2 or version 3. Windows 10 likes to do version 3. Now, there are a couple of rules when you start to implement multicast, and by that I mean that if you want to do a full-blown multicast implementation, we've got a couple of things that would be nice to be able to support. Membership of a host group is dynamic, so what that means is that you can join or leave a group anytime you want to. And the corresponding network devices will respond accordingly. So that means that your switch will know that you joined or left the multicast group. Your router will know whether you need that multicast stream or not. There's no restriction on where your host can be or how many members a particular group can have. Remember, it's 0 to any number of hosts. A host can be a member of several groups. And as we said early on, or in the last video, you don't have to be a member of a group to send traffic to that group. A host group can be permanent or transient. That means here today, gone tomorrow. There's nothing at all that specifies whether or not group presence is required. A permanent group has a well-known administratively assigned IP address. So that's the list of addresses that are managed by IANA. And you can go take a look at those with the links that I provided in the earlier video. Now, your level of conformance indicates how much you're willing to support IGMP. So we can see here that if you're at a level 0, you're not doing anything. That's pretty straightforward. Sending but not receiving versus full support. Now, in most cases, you're going to be a layer 2 or a level 2. IGMP is part of the IP protocol suite. So whether it's IP version 4 or IP version 6, IGMP, like ICMP, is a sub-protocol of IP. So that means that the minute you have a stack that does IP version 4 or IP version 6, you also do ICMP or ICMP version 6, IGMP or IGMP version 6. And of course, we now know that IP addresses are mapped to the Ethernet multicast address. This is the IP version 4 mapping, but of course there's a mapping at IP version 6 of some address that begins with FF to a frame that begins with 3333. I guess the first message that we ought to talk about here is the IGMP membership report. It's what hosts use to signal what group they are a member of or what group they want to be a member of. It's how you join a group, and it's how you signal to a router that you are a member in a particular group. It's also what the switches pay attention to so that they can do something called IGMP snooping. Now, I've got down here that IGMP membership reports are sent in response to a query, and that's true, but they're also sent all by themselves when hosts want to join a particular group or as part of the operating system. So we'll see a lot of SSDP signaling when Windows hosts start up, for example. Now, routers respond to these as well. So the routers can be very engaged in multicast streams. They can even be recipients of a multicast stream. But certainly, if we have a routed topology and we need to forward a multicast stream across that topology, the routers have to know about it. And again, hint, hint, wink, wink, routers are used to doing unicast routing. They're not used to handling multicast. So that means that we have to tell them that they have to handle multicast traffic and where the destinations are. Now, forwarded messages are a problem. You can end up with multicast traffic being flooded throughout your topology because everything is sent in the clear. There's no security associated with IGMP, at least versions 2 and 3. And here's an example of a membership report. If you look all the way at the bottom, we can see the multicast group for which this host is signaling its membership. And again, this is very common in deployments today. We see this particular address used all the time for service discovery protocol. You can see the unicast source of this particular message, 10.110.178, and then just blasted out this particular multicast address. And we can see the mapping down to layer 2, converting the lower order 23 bits to that 7FFFFA in the MAC address. So if you're following along in the chapter, this is an example pulled right from there. This will be our first example that we talk through in the video series. So there'll be a couple of more in the chapter and more detail on how I actually built things for that chapter. But in this case, we've got a host that is sending multicast traffic. So 172.31.31.15 is actually generating a multicast stream. So it's sitting there connected to the switch and forwarding out, in this case, RTP traffic to this destination address of 239.99.99.99. So that's the multicast destination. You can see that was in that Class D range of addresses. 172.31.31.1 wants to listen in, wants to scoop up all of those multicast frames. So the switch is blasting all of this stuff out. So what .1 does is it sends out a membership report to the network, and starts scooping up the stream. And so we can see the membership reports going out from that particular host. In the packet captures below, we can actually see some of the other multicast traffic, the other groups that it wants to join. Those are part of the well-known or permanent groups. And in this particular case, we can see an overlap of two packet streams. So on the left is the RTP stream that's being generated from .15. So that's why I put it in this particular slide, and it's overlapped by the membership report from .1. But if you look on the left, you can see that 172.31.31.15 is actually sending stuff to a destination of 239.99.99.99, and it happens to be RTP traffic. The packet that's sitting on top of that is actually the host, 172.31.31.1, signaling its membership and to this particular address saying, I want that particular stream. Note the destination that it uses for this address or this message, and the multicast address that's used in the IGMP membership report are the same. So what about routers? Well, I've got the frowny face here because routers don't want to do this. This is not something that we want. And if you think about it for a sec, routers have enough to do. They do not want the added overhead of forwarding multicast traffic all over the network. Because multicast traffic means that automatically every router has to not only process it, but forward it. And so by default, we do not do multicast routing. We do unicast routing. In addition, the routers by default would have no idea where they're supposed to send this traffic, because remember, anyone can join a particular stream. And what we want is for nodes to signal that they want it before we start blasting it out. So the IGMP messaging is between hosts, and we might say between sources of the multicast streams or sources of the multicast traffic and hosts that want to participate, but also to the directly connected router of that network. If we are going to forward this across a layer 3 network, then the routers have to be aware that there are hosts wishing to participate in the multicast stream. There's a couple of things that we should be aware of here. One is that we need Protocol Independent Multicast, but there are a couple of multicast routing protocols out there as well. Now, this is on top of the fact that most routing protocols use multicast addressing in their destinations. So you can take a look at both of those. We're actually going to talk a little bit about Protocol Independent Multicast because we're going to do a routed example here in a little bit. Now, IGMP snooping, or snoofing as it's sometimes called, this is the process of discovering the multicast listeners on the network. We have two goals here. One is that on the switches, it will be really great if we could partition this multicast traffic off to only those ports that needed it. Remember that by default, we're going to blast this stuff everywhere. And so if you can have a switch that either has IGMP snooping on by default or turn it on, and so on Cisco, that's just IP IGMP snooping. What that does is it tells the switch, listen, you can pay attention to the multicast traffic that's out there and only forward this to nodes that have signaled membership in the particular group. But the other thing is that we're trying to tell the routers what's happening. And so we have to let the routers know. I mean, you might have a multicast routing topology, and the routers will decide not to send it down a particular leg unless there's a host there listening. So that's a really big part of this. So the basic idea here is that routers will learn that there are multicast clients downstream via the IGMP membership reports. They can also ask if there are any folks out there that are interested in a multicast stream. And in that way, they update a new routing table called the multicast routing table so that they can forward the traffic appropriately. And then routers, we call it a tree-like structure. This is not uncommon or not unlike the unicast routing that we've come to know and love all these years, but multicast routing is just a little different. It has such capability to pollute the network. We can spam it everywhere, or we can build a little bit of a hierarchical tree-like structure, minimize the impact of multicast traffic, and we'll talk about that here in a little bit. The IGMP query is one of the other big messages that we need to talk about here. So this is when you do have a router that's present and it is willing to do multicast. And so what the router does is says, hey, anybody out here want this particular group? And it uses the all hosts. Well, let me be very clear. The all hosts multicast is something that all hosts pay attention to. But if you've got a particular stream, then you can blast out to all the hosts either particular interests in a stream or that you're going to hit everybody and say, listen, tell me everything that you have. Okay? So we've got general and we've got group specific messaging. So here's an example of an IGMP query, and on the left-hand side we've got the general query. This is going out to the all hosts address, and this is coming from the router .254. And we can see that this is just going to the local area network. It's got a time to live of 1, and it is the query, and it's the multicast address that we're interested in is essentially blank, meaning tell me what you've got. This is an example of a very specific report to a particular address. So this is in response to the query that was just issued. So in this case, the host comes back and says, hey, listen, I'm after this particular, or I'm a member in this particular group. And that's how it works. Routers query, they find out what's out there so they can forward appropriately. Well, I think that'll about do it for part 3 of 4. Next up, we're going to do a little bit of Protocol Independent Multicast. And just remember that these go with that new chapter on multicast, free to anybody that already has the ebook in the Packet Guide to Routing and Switching. Thanks for watching, thanks for listening, and may your packets always reach their destinations.